going to be talking about a few of the best practices when installing a hinge pan conveyor belt. Now, these belts they don't act like normal conveyor belts. They act more like roller chains because, as you can see, they're very similar. So this is a regular roller chain. That's your drive sprocket. And you can see the makeup of it is you've got a sprocket with valleys and you've got a chain with rollers, and those rollers go in the valleys. Well, this is the exact same for your hinge pan belt. You've got a cam on the end which rolls along a wear bar, which rolls along a bar underneath there and allows it to kind of be guided flatly along the surface. But those cams are also captured in sprockets on the ends, and that's what actually drives the chain around. So just to further illustrate, when you've got the roller chain, the conveyor belt engaged on your sprockets, this is what happens. As you move in one direction on the bottom, you'll move the opposite on the top at the same rate. You never have the top move independently of the bottom. So when you split this chain and put it onto these pulleys, like you feed let's say you feed the belt in this way, wrap around, feed it off this way, and pin it. Okay, that's great, that's easy. But anytime you have to make an adjustment on something, you have to keep in mind that as long as these two pulleys are locked in, then whatever you do on one is going to happen on the other. And if you're just engaged on the bottom, that might be fine because you can roll at this rate and you're rolling in the same direction. The problem arises when you engage the top and the bottom at the same time, because now your belt will do the opposite of what you want on the bottom. It'll do the opposite on the top. So if you want to, let's say, take one link out of here, let's say you want this cam to end up in this pulley. Well, you can't just rotate this around because this will follow everything at the same rate. So if you can even move this past the frame, then you might be lucky. But the point is, you either have to have enough slack in this head pulley where you can sort of hop this cam into this and hop this cam over here. But usually you don't have enough room in the frame for that. So what you end up having to do is splitting the chain somewhere in here, and you end up having to sort of roll it back. But the problem is, everything you roll from in one direction is going to roll the opposite in the other direction. So if you let's say you split this chain here, and you say you want to pull this top cam back so that you have room to drop this cam in. Well, how do you move this top chain away? Because if you rotate this sprocket to, let's say, pull that top chain back, what you're going to do is you're going to throw more chain this way. So you're going to roll this further over. What you need to do is get it so that the ends of the chain, so you might have to take up your slack in the middle here somewhere, or you disengage. Let's say you take your tail pulley, you take the tensioners completely out, and then you can slide the thing independent of this sprocket. Anyway, it's just a bit of a difficult situation. So you're better off right at the beginning, when you're first setting up this chain, you're better off making sure as soon as the belt is fed in this way, you've got all the cams engaged on a single point. No slack like this. Do not allow this to happen. Just set one cam for one tooth, one cam for one tooth, and you do the same on the tail pulley. So then whatever slack you have is going to be in the middle somewhere. That's the best case scenario, because at that point you can just spread these apart. Once you've pinned these together, you can just spread the head and tail pulley apart and it'll take up that slack. But if you have this sort of situation, you're stuck unless you disconnect that chain and you reconfigure the whole thing so that you can get one cam in one valley. It's a lot more work to do it this way. It's easier if you just set it up right at the beginning with your split point engaged on the cams. Now, let's say you're in a situation like this, and once you've corrected the positioning of this chain, you find you have too much slack. You can't take up enough. So now you have to take links out, just like you do with a roller chain. Well, how do you do that? Now, these are designed very similarly in that you've got pins going through, and you've got them set up so that it's designed so that it's easily removed. This plate is easily removed. You take the cotter pins out, you pound the pin back, and now this plate will separate this plate, and the pins can slide through. But these are designed in pairs, so these cams will be a pair. They don't come apart easily. You have to grind them apart or cut them apart or drill them apart, whatever. The point is, these come as a pair, these come as a pair, and these are the joiner plates in between. So when you go to take a link out, you're not really taking one link out, you're actually taking two. So you're going to take this set of plates out, and you're going to take this set of cams out, or this set of cams out, so that this next linking plate can hop up to the next cam, or this next linking plate can hop down to the next cam. Whatever it is, the point is you're not really taking one link out at a time, you're taking two. So you have to keep that in mind when you're planning your pin removal. You have to be able to take a set of pins out so that this pin can move up to here. That's just another note to keep in mind when you're positioning your chain to remove a pin. Usually you have limited access to these pins. Usually it's right at the end, you have limited access. Sometimes you'll have an access panel on the side, but usually it's just at the ends that you have access. So you have to plan it properly in your positioning so that you can take one pin here and one pin here, let's say, to take that set of links out. Here's just a close-up of those roller chains, and you can see the rods that go through each link have cotter pins. So you have to take those cotter pins out, and where each of those cotter pins out, those plates come off easily, but then you've got a set of cams that are swaged together. So you have to take both that linking plate section and the paired roller cam section out whenever you take links out, unless you got special equipment. Another note on the joining plates and the rods is that they usually are matched up like this, where there's a flat spot on the rod and a flat spot on the plate, so that the pins can't spin inside the plates. They have to go in one way. So you have to keep that in mind for assembly. On the point of chain install and removal, there's a couple little sort of tricks to doing this that make it a little simpler. For one thing, if you have, let's say it's a really heavy belt, let's say it's pretty big and you're having trouble rolling it, pulling it on by hand, you can use a winch or something, and usually you can weld like a lug onto the chain somewhere and attach a winch or a come along or something to it, and use an anchor point to sort of pull the chain through. And ironically, because of the cams and everything, the more chain you get into the frame, the easier it's going to be to pull the rest in, because the cams are starting to help you by rolling and adding their mechanical advantage to the process. So as soon as you get a certain amount of chain in here, it's usually it gets easier to pull the rest. But in the meantime, if you've got a particularly heavy one or whatever, and you have to pull it in, you might have to weld on a lug or something, attach a strap to it somehow, and then use a device to pull it on. But let's say it's light enough that you can pull it by hand. The easiest way to feed these in is to go, feed it into the bottom along the rails, around the top, and over, as long as you don't have any reason why this can't freewheel. If this can spin freely, that's your best bet, is to go in on the bottom, around on the top, and then pin it back here if you've got access. Obviously, you got to assess your situation and determine which point's best to pin it or whatever. But anyway, that's the easiest way to feed it on. In order to take it off, there's a couple ways. Again, if you can freewheel the whole thing, then you can split the pin back here, lift the top so that it's disengaged, so that it's not going to roll around, back around into the system. You just lift this end up and then pull this back, and the whole thing will feed off as a unit. Another option for removal, if the tail pulley is a manageable size, you've got the room and the frame style for it, what you can do to take it all off as one piece, instead of having to feed it all the way around. Let's say that's a really slow process to feed it all the way around, or it's a really heavy belt or something like that. This might not be feasible, but it could be. So you have to assess that each time. But if it's feasible, what you can do is disconnect. Let's say this is your head pulley. Disconnect your head pulley from your drive system so that it can freewheel. Split your chain here and then roll it to this point so that your split point is here, able to drop out of that sprocket on its next rotation. And then you disconnect your tail pulley from its tensioning system. Let's say you can slide it right out of the frame or lift it right out of the frame, whatever it is. Then if you've split this and rolled it to this point, then basically you just pull this whole system back and it'll take the top and bottom as one unit all the way out of the frame together. And that might save you a bunch of time depending on how hard it is to roll that belt around. If you're in the situation where you're going to try and reinstall a belt and you've got your top and your bottom belt and you want to slide them both in at the same time, then what you have to do is you have to leave one tail longer than the other, so your top or your bottom, but I would prefer to do the bottom. You leave the bottom longer. Basically you leave enough that it can wrap around the sprocket before the top engages the sprocket. So you leave enough so that as you slide these on there together, you've kind of got the bottom further ahead so that it can wrap around that pulley. And why you want to do that is so that you can get that relationship right off the bat. But also when you're doing that, you got to keep in mind that this tail pulley, if this tail pulley is engaged in the teeth, you can't freewheel this belt anymore, because as long as top and bottom of the sprocket are engaged, again, every distance, all you move this way will move this way and vice versa. So if you go to feed this on, you have to leave the bottom of the sprocket disengaged, or the top of the sprocket disengaged as long as possible until you've wrapped this around. And then once this tail pulley is kind of reinstalled in place, now your relationship is correct, because your top of your belt, let's say you left it enough so that the bottom belt wraps to this point and your top belt gets to this point. Well, now you can simply roll the whole system and pin it back in there. But if you haven't done that correctly and left yourself enough room, then you're going to end up with this situation where your tail sprocket is going to fight your head sprocket. So you just have to be a bit strategic about how you feed that in there, because you can't feed them equally. Otherwise, unless you have enough room to wrap around that. But as soon as you engage top and bottom here, you're not going to be able to roll anymore. So you can't just like pull this belt this way and this belt this way. You have to always be going in one direction. So for those of you that didn't get what I was saying from the drawing that I made, here's an actual hinge band conveyor that I can show you with. So if you wanted to pull this belt off as one piece, right, that's a lot of belt to pull all the way through. If you have to feed this by hand, or if you have to use a winch or whatever it is, that's a lot of belt to move. So to save yourself time, if you've got the space and if your conveyor is designed well, so this conveyor is designed with the slots open on the end, so the head and the tail pulley can just slide right out of the frame if you disconnect the tensioners. So this being the head pulley, what you would do is you'd split your drive chain, right, or otherwise separate this drive system from the head pulley so that the whole conveyor can freewheel without fighting the gearbox. Then what you'd want to do is, because you've got an access point here, you'd want to take the pin out of this belt, let's say here, and then you'd want to roll your belt back to the point where that point you just split is behind this tooth, let's say. So once you've done that, then what you would do is you would head down to your tail pulley and you would disconnect here from your frame so that this whole tail pulley can come right out. So you disconnect on both sides, and then let's say if it's really heavy or whatever, you weld a lug onto here, or you otherwise feed a strap through the belt or something, and then you'll pull from here, wheeling at that end. As soon as that top is disengaged, your bottom will slide freely, so you can just pull the whole tail pulley, top and bottom of the belt, all out as one unit. And then when you've pulled your belt out, top and bottom all together, depending on how you're set up and everything, you might want to feed it back on the way you know, the other way where you feed it on the bottom, wrap it around the head, and come back. But if you want to, it's a little faster if you've got the setup for it. Basically, you make sure your bottom belt is still longer than your top of your belt by, let's say it's 4 links, 4 teeth of the sprocket. Basically, you want to leave enough on the bottom, enough extra on the bottom, so that you can wrap around the head pulley at the other end. When you feed it on, you want to be able to wrap around the pulley. So let's say that's for this chain, maybe 3 links. So you leave 3 link extra on the bottom and 3 links shorter on the top. And then you feed this on all the way to the end. You wrap your head pulley. But just before, basically, you want to make sure that when you're doing this, that you haven't let one of these teeth skip. You need to make sure that as your tail pulley is being reinstalled in your belt, that you have maintained one tooth for one or one cam for one tooth. You need to maintain that relationship on both ends. Otherwise, you're going to end up in a kinking situation. So, as long as you've maintained that sort of distance and you've wrapped it around, you're careful and strategic about it, then that'll go on pretty smoothly.